Hey guys. Alright, a while ago we did a Doceri video for problem number 3, and we worked out that by hand. This time, I'm just having a video off the iPad, and so bear with me because I'm not sure how the camera's going to work on this. Okay? Alright. First thing we're looking at is we are going to look at problem number 7. Okay? Problem number 7 says a player hits a tennis ball across the court and records the height of the ball at different times as shown in the table. And we've got three questions it asks. Find the quadratic model for the data. That's the equation for the graph. Then we're going to use the model to estimate the height of the ball at 4 seconds. And then we're going to find the ball's maximum height. So what's the vertex point? Okay? Excuse me. Alright, let's pull our calculators out here. And the first thing we're going to do is, first thing I'm going to do is try to get some glare off of there. There we go. We're going to look at our times. We've got 0, 1, 2, and 3. We have a height of 5, 5, 6, 0, 5, 5, and 4, 0. Okay. Now, we're going to put these numbers into our calculator. So we're going to go stat and edit 1. And then I've got 5, 5. So, let's try that again. We're going to do our x's, which is our L1. So we're going to do 0. And then 1, and 2, and 3. Okay. And then we're going to record our height. Height at 0 seconds was 5.5. At 1 second, it was 6. At 2 seconds, it was 5.5. At 3 seconds, it was at 4 feet. Okay? So now we've got our 4 points in. Let's go to our y equals. We're going to turn on our plots so that those can be graphed. Okay, so I'm going to arrow up and I'm going to hit enter to turn those on. See, they turn black. Okay, and enter for plot 2. Now those are both turned on and we can see the black square around those. Okay, let's see. I'm going to adjust my my windows. I'm going to have a feet of, or time is my x, so I can't go less than 0 seconds. I've got 3 seconds and it's already going down towards the ground. I'm going to go ahead and leave my maximum at 10. And I'm going to set my 0 for my y minimum. And I'm also going to leave my max at 10 because it looks like I only went to a maximum of 6. So we'll just leave it at 10 on here. Okay? Now let's graph it out and let's see what our graph looks like. We've got definitely a parabolic curve here going down, correct? It started going up and then it turned and went down. Okay. Now, the next step is that we are going to get our quadratic equation, or do our quadratic regression. So I'm going to go stat over to calc and number 5 for quadratic regression. Okay. Now yours might already say quad reg right here. That's fine. Enter it on. Just hit enter. If yours looks like this, just enter all the way through. Okay, so this tells me that my equation is y equals ax squared plus bx plus c. That's my standard form. My a is negative 0.5. My b is 1. My c is 5.5. Rachel, would you get me a pen? I just realized I didn't have a pen. That is a stylus, not a pen.
No, your bag is right.
I am trying to record. Can you please?
I'm doing it.
Okay. So, if Rachel would hurry. Okay. Hopefully that is good enough. Alright. So, we have y equals, I've got negative 0.5, so negative 0.5 x squared, and then b is 1, so plus x. Remember, if b is 1, I don't have to put the 1, and then c is 5.5, so plus 5.5. Okay, now let's try that equation and put it into our y equals and see if that works for our points. So y equals, we've got negative 0.5 x squared plus x plus 5.5. Okay, enter there, and let's graph. That fit real nice right there. Yep. Okay, now it says use the model to estimate the height of the ball at 4 seconds. Okay, to do that, I've got 0, 1, 2, 3 seconds on my points.
Nope.
4 seconds is right in here. Let's go to our table and let's take a look. So I'm going to go second graph to look at my table. And I'm going to come down here to where x is equal to 4. And at 4, my height is 1.5 feet. So 1.5 feet. Okay? Now it says, what is the ball's maximum height? Okay, let's go back to our graph. And we're looking for the maximum height. Now, my graph goes down, it opens down. That means my vertex is the maximum height, correct? Let's figure out where that vertex is. Maybe it's at that 1 second at 6 foot. Maybe it's not. Let's go find out. Okay, we're going to go second trace. I'm looking for my maximum. Okay, my left bound side. Let's make sure we're over there. Let's see. Looking for there's our blinker. Okay, coming around over here. Now I'm on my left bound side. I'm going to hit enter. I'm going to arrow back over to the right bound side. You see it's blinking right here. Okay. Now right bound side, I'm going to hit enter. See that set up my left bound and right bound side of my interval. Now I'm going to try to find the maximum height here. Okay, so the maximum y is at 6. So at 1 second, it is 6 feet high. So the ball's maximum height is 6 feet. Okay? Alright. I want you to do number 9 on your own. Okay. Alright. Now, I want to show you how to do number 11 and 13. Okay? Number 11. Let's look at this. It says determine whether the quadratic model exists for each set of values. If it does, write the model. Okay. Number 11. Now, I have f at 0. So when f of x equals something, and we use x for 0, y is equal to 5. So that means I have 0, 5 for a point. Okay. Here I have negative 4, 13. Negative 4, 13. And here I have 2, 7. So 2, 7. Okay? Alright. Let's go clear this out. Second plus 7, 1, 2. Clears out our data. Okay. Now, I'm going to go into stat. And I'm going to put an edit. I'm going to put these points into my equations here, into my lists. So my list 1 is my x's. So 0, negative 4, and 2. So 0, negative 4, and 2. Okay, there's my x's. My y's, 5, 13, and 7. 5, 13, and 7. Make sure that you put them in exactly that order. Don't try to put them in numerical order, chronological from 0, from least to greatest. We've got to have them match up. Okay, so 0, 5, negative 4, 13, and 2, 7. Okay, now I'm going to go do a quadratic regression. So stat, arrow over to calc, 5 for quadratic regression. I'm going to enter through here. Okay, it tells me that for A, it's 0.5. For B, it's negative 3.6 e to the negative 13. That is a scientific notation. Means that I have a point, and then it's negative point, and then 12 zeros, then 3, 6. In other words, if I round it to 3 decimal points, it's 0. Okay? And then C is 5. So, my equation for this one, because it does have an A, that means x squared is 0.5x squared. As long as I have that square with that x, then it is a quadratic equation. If I do not have an A, if A is 0, and then B has something, and C has something, then if my first x is just a single x, then it's linear. Okay? And so if I have a 0 for the x squared for the A, then I do not have a quadratic equation. Okay? So let's write this quadratic equation out. We have y is equal to 0.5x squared. Remember we said when we round negative 3.6 times 10 to the negative 13, that means essentially I have a 0. So I have no b. So the 0x, and then plus c is 5. So I have y equals 0.5x squared plus 5. Is there a quadratic equation? Yes, this has a quadratic model. Okay. All right, I want you to do number 13 on your own, and let's see what that one comes out to be. All right, thanks for listening, guys. I hope this helps. I do want you to do number 5, number 9, and number 13 on your own. Okay? If you have any questions, post them or text me, okay? Thanks. Have a great night. Bye.